Okay, and share. Is that the right one? Yeah. All right, can you all see my screen? Excellent. So that was the introduction to the course. Learn a little bit more about me, what we're going to be working on in this, I guess, Python scripting data analysis class. We learned a little bit more about what a data pipeline is, and we learned a little bit of sort of motivation about why we would even do this in the first place. So today, this is going to be a lot more similar from now on to what we're going to be doing on a day-to-day or class-by-class basis. So we're going to have a series of topics that we're going to want to cover. We're going to have coding examples, and then I'll also open up a Python, a Jupyter notebook to walk you through some examples of some different coding. So with that being said, I introduce you to, oh, sorry, that was anticlimactic. Okay, so this course is divided into 5 modules. The first one is data. What is a data pipeline? And we're going to also learn about the foundations of the Python programming language. So for instance, we're going to learn about values, we're going to learn about data structures, we're going to learn about iterations, conditionals, and functions, more or less. So once we learn about the core foundations of how to use Python, we'll be able to leverage them for analyzing data, which moves us into module number 2, which is structured data. Once we go from structured data, you'll get more comfortable with using the tools and the toolkit to analyze data. Structured data is an easy introduction because you know exactly how to ingest or consume this information. And then I'll move us over to semi-structured data. So the semi-structured data, an example would be HTML. It's semi-structured because it doesn't fall nicely into rows and columns, but it does follow very strict patterns and is easily converted from one data type to another. From there, we move on to the, I guess, most complex would be unstructured data. So this is usually free text or log files. And more often than not, this is sort of the hard programming problem that most machine learning or data science algorithms struggle with. A lot of times, if you're familiar with something called natural language processing, this is falling into that unstructured data territory. And then module 5 is final projects, and it should say final projects and other topics. So once we get to the end of the semester, we'll have a better sense of what everybody's interested in, and we can do some additional topics probably for the last 2 classes of the semester, and they'll be a little bit more open-ended, and you'll be less responsible for the material. They'll be more like just kind of like long presentations about different analytical types. Any questions about sort of the structure of the course design? Okay, I think silence is a good sign. So a little bit more detail about pipelining and Python foundations. We're going to be learning about the overview of data analysis and the data science processes. We're going to be working on acquiring and selecting data for structured problem solving. And the main part of this module will be learning the material in the Python for Everyone text, which again is available online. And I believe there are 15 chapters, 5 of which you will hopefully have read by the next class. Now, big caveat, this is not a computer science class. This is not a class about software engineering. This isn't even really a class about proper programming techniques. This class is specifically designed to learn Python for the purposes of data analysis. But there are classes at SU that focus on things like software development and computer science that also use Python. So if you find this course interesting and you really want to learn more about Python and want to learn more about software engineering, I highly recommend that you look at other graduate level courses at SU to accomplish those ends. Okay, so once you know more about Python, we'll begin looking at structured tables and data exploration. So good examples are CSVs. CSV stands for comma separated values, and these are this is structured data such that each value is separated by a comma, and then each row is separated by a line break. And that's sort of the basic design of a common comma separated value table. In addition, we're also going to look at Excel. Excel, like I mentioned earlier in our conversation today, is still very popular with most analysts and organizations, especially larger enterprises that have leveraged Excel for a lot of their analytical processing. So there still may be opportunities to read and write from and to Excel, even in today's modern data architectures. In addition, we're going to be exploring data techniques for data cleaning, outlier analysis, data transformation, and then in terms of results, we're going to be kind of working on like summary statistics and things of that nature. So moving on from structured data, we can move to semi-structured data. By the way, I'm going to take a quick pause. I heard that I was not very easy to hear. Am I still easy to hear now? Is it still a good volume and everyone can understand what I'm saying? Awesome. That's what I like to hear. Very good. Okay. So moving on to semi-structured data. So a couple of examples of semi-structured data are as follows. You have JSON, which is a really common application interface. So when one application wants to query information from another, they'll usually use an API. And the most common response from an API is something called JSON. JSON is key value pairs with either strings or arrays of values. Another common one is HTML, and this is the common framework for website design. So JavaScript is sort of a more, I guess, variable and conditional, but HTML is a structured textual format for classifying areas of a website, even if it is dynamic through something like CSS or JavaScript. And then lastly, another common one is XML. XML is an alternative for document storage, most common, and it uses similar architectures to things like JSON. There is a question. What's the question? Yes, there is no question. Okay. We'll also have an opportunity to work with MongoDB and NoSQL databases. So anybody that's familiar with SQL is probably familiar with the ability to relate different tables in a database, query them using selects and from clauses. In NoSQL, we're going to learn about a little bit the structure of those types of databases and how you can interact with them using Python. And then, again, in terms of results, we'll similarly be using summary reports and statistics in lieu of something like a data science model. And then lastly, we're going to look more at unstructured data. So specifically, a really good example and a common example is log files. And log files are usually the output of some process, either analytical or application-wise, that determines the success or failure of particular processes. I have a question here. Is NoSQL database the latest trend in companies? NoSQL databases are great for particular types of data storage. Specifically, if you have a very flexible or variable data structure. So for instance, clickstream capture. I mentioned this earlier during the Airbnb example. If you don't necessarily know all of the different things that you want to capture, it's much easier to store it in a NoSQL database because maybe I collect 15 different things about that data capture. And then later I add a new element to my website, and now I want to add that to my data capture. So now it's 16 elements. In a traditional SQL database, it's very difficult to change the architecture after you've already designed the database. But in NoSQL, it's much more flexible to have different data object shapes. So depending on the way that you're collecting and storing the data, NoSQL is great for, let's call it, semi-structured log capturing with JSON. JSON is a very popular NoSQL database collection mechanism. But in terms of the classic relational data model, that still has a very valuable aspect in companies as well. So to answer your question, NoSQL is very great for particular types of data storage, but it's not the only solution to particular problems. I think it's just one of many that can solve different problems. And also MongoDB is not the only NoSQL database as well. There are other ones that are also quite common. So for instance, my company uses one called Cassandra. Cassandra was developed by Facebook a couple years ago and then was open sourced as part of the Apache project. Any other questions about unstructured or semi-structured or structured data? Okay. Great. So in terms of looking at log files, which again are unstructured data, it's usually just in something like a .txt, which just stands for .text. We'll use tools like regular expressions. Often this is called regex or regex, depending on the syntax that you prefer to call it. And using regular expressions, you can do pattern matching with respect to the data that you find in log files. It's a really easy and helpful tool in creating structure from unstructured data. And the only way that you can truly analyze data is deriving some structure from the log text. Now, note NLP is a very common set of algorithms and packages and toolkits that are available, but that's something that we're not going to focus in this course. There are entire NLP courses offered by the iSchool if unstructured data has piqued your interest by the end of the semester. Okay. And then there's the final project and additional topics. I'm leaving this blank simply because we already discussed a little bit about the final project and the requirements for both the final project proposal as well as the final project deliverables are both on Blackboard. Any questions about the final project? Okay. All right. This is the fun stuff now. We're going to finally learn what this Python thing is that we've been talking about for the last 2 hours. So what is Python? Python is a tropical snake Python is a programming language, specifically a general purpose programming language, which is designed initially designed to help students learn how to code. It was actually designed as an introduction to the computer science lingo in the mid-90s. But this is not a course on the history of Python necessarily, but from the official Python documentation, Python is an easy-to-learn, powerful programming language. It has efficient, high-level data structures and a simple but effective approach to object-oriented programming. Python's elegant syntax and dynamic typing, together with its interpreted nature, make it an ideal language for scripting and rapid application development in many areas in most platforms. So what does that all mean? It's easy, it's intuitive, and it's cross-platform compatible. So for our use case, and really the analytical community, both academic and enterprise combined, has become a go-to source for leveraging and developing data pipelines and analytics. So Python has really taken hold of the data science, data science spectrum because of the ability for people to interact with it in many different ways. You can design end-to-end applications in Python. You can do a full-fledged data analysis in Python. You can develop advanced machine learning technologies in Python. You can develop web interfaces in Python. And because you can do all of these things using the same tool, it just gives many different people in the same organization a common language to speak when doing their work. So because of that, there's this idea that Python is so flexible that it just kind of brings different areas of technology together. And how will we use Python in this class? So there are three, for our use case, sort of three primary application interfaces. One, you have a standard text editor. Does anyone not know what a text editor is? And I'm not talking about like Microsoft Word. I'm talking about like plain text editor. If no one, you're also welcome not to chime up if you haven't. So a text editor is an opportunity for you to code in a very flexible way. It just takes plain text, and a lot of times if you save it as a .py file, it'll automatically start formatting it in the syntax of Python. So Python leverages a lot of white space, or spaces or tabs, as I guess a way for the code to be interpreted. And specifically, the text editor that we'll be using in this class is called Visual Studio Code. This is a Microsoft product, which is actually really cool, and is also available on all of the lab computers at SU, or at the iSchool. The big thing about text editors, though, is that they don't run the programs. You can't use a text editor to run a Python program, as far as I know. There are some text editors that double as IDEs, but Visual Studio Code, as far as I know, does not run the Python program. Then there's an IDE, which stands for an Interactive Development Environment. And for this class, we're going to use something called Spider. Spider is part of the Anaconda distribution that I asked you all to download, and hopefully you'll have that downloaded on your personal computer by next class. And it's Python 3.7 or 3.6 or 3.5. Just has to be Python 3.x. Do not use Python 3.2. Do not use Python 2. Python 2 is not going to be a supported language next year, and there's really no value in, especially for newcomers to the language, there's no value in you learning Python 2 over Python 3. Lastly, and my personal favorite, the web application interface. So there's this great tool called a Jupyter Notebook, and again, it's also part of the Anaconda distribution that you've downloaded, and it allows you to run a program stepwise. So something like an IDE, you feed it an entire program, and more or less it runs the whole thing all at once. While a Python notebook will only run the sections of the code that you want and will give you intermediate outputs. And we're going to explore a little bit later about what that looks like. But what it allows you to do, it's great for data analysis, because data analysis, you often don't know what the end of your code is going to look like until you make small iterable or iterative steps. You might want to say, oh, let me consider what I do to this set of data. And then you change that shape and you go, oh, now let me do this. So you do a lot of the steps very piecewise. And Jupyter Notebooks allow a very cohesive environment for doing so. So just as a snapshot, this is what Visual Studio Code looks like. It's a fun environment. And it, maybe you can run code in Visual Studio. Yeah, I was wrong. So you can also use this as an IDE. Spider was sort of designed as an IDE designed for data scientists and then adopted by the Anaconda distribution. It's the IDE of choice that I use when I need to run Python, not in Jupyter. And then lastly, Jupyter Notebooks. Jupyter Notebooks are great because it also allows for markup. So you can add like free text to an area of the notebook. And then anybody that's familiar with the research language, it's called LaTeX. It does a lot of markup for mathematical formulas or great formatting for more research level interactions. And it's compatible with Python, Jupyter Notebooks. Now, FYI, on the internet, if you ever see something called an IPython notebook, it's the same thing as Jupyter Notebook. Jupyter, the company, or maybe they rebranded IPython notebooks to Jupyter Notebooks, but they are one and the same. So they are cross-compatible. Jupyter Notebook is just the modern implementation of IPython notebooks. Submitting assignments. So labs, specifically, you can submit either a Jupyter Notebook or Python scripts. Please just mark them up. Just as many comments as you can put that will help me better understand what you're trying to do, the better. And we'll talk about what it means to properly comment code, and I'll also show you how to properly add text and markup in a Jupyter Notebook. In terms of finals and the mini projects, the expectation is that you provide a Word document, which gives me more structured documentation. Think of it more like the supporting business requirements or reporting that would go along with a more thorough analysis. And then the same goes for the Jupyter Notebooks and Python scripts. And as a reminder, please install Anaconda on your laptops by next lecture. And the link to Anaconda is in the syllabus, and go for Anaconda 3.7. Conclusions. This is the Python that we're going to be working with. We're going to be primarily doing the work in Jupyter Notebooks, but again, you are free to do the Python in any environment on your own that you wish, as long as you can submit to me either a .py file, which is the standard Python file, or a .ipnb file. Either of those I can interpret and grade and assess. Any questions about the expectations around how we in this class will be using Python? Okay. Very good. Moving on. Oh, no, no new questions. Okay. So within the Python community, someone that is enthusiastic about coding in Python is called a Pythonista. So let's start becoming Pythonistas. That's my go get 'em attitude. Here we go. So I'm now going to share, if I get it right, Jupyter Notebook. I just need to find it. All right. Nope. Am I sharing? I'm not. All right. All right. Can everyone see my screen? Very good. Very good. Okay. Welcome to Jupyter Notebook. Jupyter Notebook is a web application interface. And what that means is it runs in a web browser. Now, even if I go offline, I can still use my local Jupyter Notebook in a web browser. It does not need to be connected to the internet because it's using something called localhost. Localhost just means that it's running on your own machine. Now, you can also, there are instances where you can access Jupyter Notebooks remotely. So you can access, instead of localhost, you have access like a server somewhere. But for our purposes in this class, you're all going to host Jupyter Notebook locally on your machine through the Anaconda distribution. So today, we're going to be focusing on two things, strings and numbers. So I guess let me go back and see if anyone posted in the thread about familiarity with Python. Let's see. Python. Tell me if you've ever used Python. Okay. Okay. All right, we have at least one never. All right, so for the most part, a lot of you have some familiarity with Python, which is great, but I'm still going to assume that we're starting from scratch so that everyone can be included. So we're going to start today very, very simply with text. So just as a precursor to Python, in a notebook, you have these things called cells. So right now, I'm in a cell, and I can type. And in order to submit a cell to be executed, you want to hit Control and hold it. I'm sorry, you want to hold Shift and then hit Enter. And now we've seen our first Python error. This is not defined. That's beautiful. Now it's gone. Okay, so again, if you want to execute a cell in Jupyter Notebook, it's Shift, Enter. Look at that. Shift, Enter is a string. This is a string. These are strings. And so is this. But notice that both 47 and 48, these two cells here, they're using different characters to isolate strings. And it's a thing, it's specific to Python. Python allows you to encapsulate characters in both double quotes or in single quotes. Both of them will identify and isolate a string, but you cannot just combine them. You can't say single quote, testing, double quote. This will fail. So once you open a string with a single quote, Python is going to expect an additional single quote to close out the pairing. So each set of string needs both a start and an end quote in order to encapsulate an entire string. So testing is now proper because it has both a single quote to start and a single quote to end. This is also a string. And strings are a data structure and a data type in Python. The data type is abbreviated str. So we'll learn a little bit more about what data structures are and as well as data types. But a data structure is a collection of values in Python, and a data type is just that. It's a specific type that Python has defined that represents what types of values can be represented in that type. So for instance, a string is any Unicode character. And we'll talk a little bit later about Unicode, but it's any character that you can type on a keyboard, more or less. Now, this is going to be our first function in Python, right? If we want Python to tell us what type a value is, you just use a function. And a function is a special object in Python that takes values and returns outputs. So this took in the value, this is a string, and returned the value str. That's because it's determining the type that Python recognizes this value as. And it recognizes that this is a string, and it recognizes this is a string type. So this is our first function. How's it feel? Easy stuff. Look at you guys. You're already learning all about Python. It's only the first day. So much to do. Now, the most common first thing to learn in any programming language is to learn how to print hello world. Now, in other languages other than Python, it can be very difficult to do this. Let's do hello world in C. I think it's complicated, if I remember correctly. Yeah, here we go. If you wanted to learn hello world in C, look at all of this stuff. Look at all that. That's nuts. That's outlandish. You don't need 6 lines of codes to print hello world. Python, you need 1 line. 1. You only need 1. Here it is. This is our second function that we're learning. We're learning the print function. So here, we're going to learn print. It's going to take in the value, hello world, and it's going to print hello world. But notice that in a Jupyter Notebook, if you just return a cell, it prints it right out in the web page. So we have hello world printed out right here. But notice that it's also in single quotes. We can do the same thing if we actually use the print function. So here, we use the print hello world, and it loses its quotes. And that's because it's using the interpreter to actually return this value as the standard output from Python. Now, if you just hit hello world and you weren't using a Jupyter Notebook, you were using, for instance, an IDE, it would throw an error because you're just passing a value without telling it to do anything with this value. Jupyter Notebooks just inherently post things back to the web page. It's part of the Jupyter Notebook, I guess, environment, and it's personally why I think it's really helpful, because it prints things right to the console without having to call print. Now, also notice that in this same line, I have some text that's not being interpreted, and that's because I'm commenting it using a hash. So if you do hash or pound, nothing after that on the same line will be interpreted by Python. This is called using comments. So here I've commented out the fact that notice that this quoting will disappear when I hit print hello world. What happens if I remove that? I'm going to get an error because now Python is going to try to interpret this as code, but in reality it's just a comment. Now look here. I'm going to do the same here. So this is called a block quote. A block quote is similar to a hash quote in the sense that you can pass anything on a single line, but you can also do line breaks. If you wanted to do line breaks with using the hash comment code, you would have to put a hash on every line, and it would become very tedious. But with block quoting, you can do line breaks. But you'll also notice that the output from the Jupyter Notebook yields these things, /n, /n. It's because it's interpreting the line break as the encoded version of the line break. But if you take the same block of text and pass it through the print function, it won't print the line breaks. I'm sorry, it will intuit the line breaks and it will not print them as /n. So there is a difference between using the if you're using the Jupyter Notebook version and printing to screen here, versus using the print and printing to screen here. So that's all about strings. Strings are very simple. Strings are a data type, and in fact, the reason that they're a data structure also, it's because it's a collection of objects, and a collection of objects means that you can take some but not all of these objects. So let's take, for instance, hello world, right? It's a string, and we can test that. Yep, it's a string. And what you can do in Python is you can select values from a data collection. And specifically, the data collection type of a string, you can select maybe the first element. And notice that we're starting from the index of 0. So this is element-wise selection. So what's the first element of the word hello world? Or the phrase hello world? It should be H. So by selecting the first character from the string hello world using indexing, this is an example of where Python is leveraging its data collection attributes of a string as opposed to just its data type string. If you wanted to select the second letter of the word hello, you would index it by 1. But what if you wanted the first 3 characters of the word hello world? You can actually, it's called slicing, and you can index by a range of values. So let's say I want to start with the index 0 value, and I want to go all the way to the index 2 value. This is going to yield 2 characters from the word hello world. I have a question, one moment. I guess you can put commas to do it. Do you mind explaining a little bit more of what you mean by that statement, Paul? So if you want to select, for instance, 0 and 2, it's going to throw an error. Is that what you're asking, Paul? Yes. So you cannot discretely select individual indexes. What you can do is index the same string multiple times and perhaps concatenate them. And we're going to get to these different functions. So imagine you wanted the 0 index and the 2 index. This is going to take the 0 index, and this one's going to take the 2 index, and it's going to concatenate them into HL. It's probably the best I can offer you in terms of discretely selecting index values. Now, this gets us to a variable. A variable is sort of like a placeholder in Python. One more comment, one moment. Great. So a variable is a placeholder in Python, which allows us to set particular either outputs or values and hold them in place with something that we're defining. So here we're defining my first variable, and we're setting it to the value or the string hello world. Now that I have this thing in hand, this variable, what am I going to do? Right? We created a variable, and this class is all about data, right? We can do anything now because now that we have a variable which is data, and now we want to analyze it. So we can actually now print it. We can print this variable. We know that it represents hello world. We can create a second word. We can create a second variable. We can print that too. So now we have hello world. It's me. So what if I wanted to put these together, right? I want to collapse them. And I showed you this briefly earlier, but we have this idea of concatenation. So if I want to concatenate these two variables together, I use the plus sign. And in this context, the plus sign means concatenate when we deal with the string data type. But that's not very pleasant, right? There's no separation. There's no nothing. Like, how do I make this a little bit more properly formatted? So can anybody type into the chat how I can make this more pleasantly formatted using my first variable and my second variable? Don't worry about doing it on Blackboard necessarily, but maybe just if someone wants to enter it in the chat in this this comment. So Paul, you're recommending a reverse /n. So I could do like a line break. Okay. Where do I put that though? Where is that going to go? Do I create a new variable? How do I concatenate a reverse /n? All right. So Alan is recommending the following. Okay. And so is Bradley. So let's give that a shot. Very nice. So what we've done here is we've actually concatenated 3 strings. 2 of the strings are held by variables, i.e. my first variable and my second variable. But then we also have this non-variable value, which is simply a space separated by 2 quotes. And by concatenating my first variable and my second variable separated by this, we get now a more pleasantly formatted hello world, it's me. And we can actually set this final output to a third variable. And this is the magic of computer science, in my opinion, or programming languages. Woohoo! Hello world, it's me. Ah, okay. So Paul, let's see if I can try to implement yours as well. Okay, so when we print it out naturally using Jupyter Notebook, we get with the /n, but I bet if we wrap it in our print function, it will interpret the /n as a line break. Very good. Very nice. All right, so that's a little bit about strings. And then we're going to wrap up today's lecture by touching on numbers. Does everybody remember what numbers are? Because we're gonna kind of relearn them from a new perspective. So who can tell me if this is an integer or a float? This first value 7. This one right here. You can go ahead and type it in the little comment box. Okay. Can someone type in that box why it's an int? What their definition of an integer is? It has no decimal. Okay. Whole number has no decimal. Very good. Yes. An integer falls along the natural number plane and has no decimal, i.e. it has no remainder when divided by 1. So here 7 is going to be represented as an integer, and we can test this. Integer, or int, is a data type in Python. I'm sorry, that was a wrong thing. Here we go. type. Great. 7 is represented as an int. But what if we wanted to represent 7 instead as a float? Is 7.0 a float? All right, I have one yes. So let's take a test. So if I do type 7.0, it's a float. And we can also use these same types that are output. All of the types in Python are also functions. So you can cast something from one data type to another. So for instance, we have 7.0 as a float, but what if we wanted it to be an int? So we take 7.0, cast it as an int, and it returns 7 without the decimal place. So that's the fun thing about Python. All of the data types themselves are actual functions. Okay. Is 7 plus 7.0 a float or an integer? Great. 7 plus 7.0 is a float. And that's because Python has a series of precedents where certain data types takes precedence over others. So here, there was a decision made when the programming language was developed in such a way that floats took precedence over integers. So that in the event that you added an integer to a float, the decimal point wouldn't invalidate the integer data type in a way such that the integer would be perfectly valid to convert it to a float and add it to the other float. So for instance, if this was 7.5 and we tried to cast it as an int, it's just going to chop off the unnecessary parts. So it's going to round down, which is really bad math. In reality, we want this to be a float. It's 14.5, because that's a more accurate number, 7 plus 7.5. All right. And more or less, that is my Python lesson for today. Strings and numbers, variables, comments, and functions. We did a little bit of it all. Now, the only other thing I want to show you is where you're all going to be by the end of the semester. Before I move on, are there any questions about this super brief introduction to Python, strings and values? You're going to learn a lot more between now and the next lecture from the text, and we're going to jump right in there in 2 weeks, and we're going to get involved immediately with functions, iterations, conditions. But with respect to what we showed today, do you have any questions so far? Okay. So let me now quickly demonstrate for you the genesis of your partners. So for the advanced group project, everyone needed to be partnered together, as well as everybody had a group number. So what I did was I loaded as data all of the students from my slice. So again, I'm demonstrating not so that you understand. I'm simply demonstrating the expectation by the end of the semester, this is the type of thing you should be able to do. So I'm sort of setting the bar ahead of time so that you'd be like, oh, at the end of the semester, I can definitely do this now. So for instance, here I'm setting a variable to the location of something called IST652 students.csv. So it's a comma separated table. So this is structured data. I'm then loading it into Python and I'm printing it. So here we have, let's call this the row header. And we have all of the students in this class. So we have A. Bailey, S. Bajpai. Not quite sure how to pronounce that. My apologies. We will cover all name pronunciation during next lecture. Q Chen, B Choi, as we go all the way down the list. And I've ingested this as a data type called a list. A list is an array of, I guess, type independent values. So for instance, you could have a float, an integer, and a string, all part of the same list. But this is specifically a list, and then wrapped inside another list. So all of these individual combinations of first initial last name, each of which is a list, is part of a greater list. So it's a list of lists. From there, I wanted to clean it up. I wanted it to be a little bit more user-friendly. So I took it from first initial last name in a list to just a value. So I said a.bailey, q.chen. And I used some more advanced features and things that we'll touch on later in the semester, for instance, called list comprehensions. It's the ability to evaluate a new list in line from an existing list. From there, I now have a list of students, and I want to pair them, but I want to pair them randomly. So I imported a package, and I did that up here. Where did I do that? I did it up here. I imported a package called random. So for the advanced presentation, this is where the notion of libraries and packages and modules comes in. I'm going to use these three terms interchangeably throughout the semester because more or less it's sort of like a hierarchy. But I've imported a package here called random. And within the random package, there are particular functions and methods. For the purposes of this class, the difference between function and method is just the order that you use them in syntax, but they do the same thing. They are an operator. They execute some sort of, I guess they execute a function. They take an input and return an output. So here I'm importing the random package so that I can use the function which randomly selects a value from a list. So if you have a list of all of the students in the class, I import a function, I import the package called random, and I use a method called choice. So for instance, I can randomly choose now any student from this list. And I did that here. I didn't do that there because I didn't import it. One moment. Not quite. My apologies. I need to put this stuff back in memory. There we go. All right, now I can. So now I can randomly choose a student from the list. And if I keep running this code, it's going to keep choosing a random student. There we go. I've noticed that A. Bailey has been chosen quite a few times, which is a bit of a statistical anomaly. But nonetheless, this is what importing a library or importing a package does. It allows us to use new functionality that falls outside of the core functions of Python. That is funny. Okay, so now that I can choose random students, I want to pair them. So I want to choose two students randomly from this list of students. And I want to make sure that, first of all, it's not the same student that I choose. So this is going to be the first time I'm using a conditional iterator. And specifically, I'm using something called a loop. And more specifically, I'm using something called a while loop. So effectively, it's going to keep doing an operation until some criteria is not met. So I want to keep choosing people at random from this list until they are unequal. That way, if I choose, I don't know, if I choose Bailey, if I choose A. Bailey twice, choose again, because I don't want A. Bailey to be partners with A. Bailey. And then once I've chosen them from the list, I want to remove them from the list. That way I don't put them, I don't want to make them have to do the presentation multiple times. So I'm iterating through the list, and then I'm deleting them from the list. So now all of my partners are paired by running through this code I've written. Hooray, they are paired, which is great. But now I want to assign them a group number. So what I do is I create a new list of groups here using another list comprehension. So now I want to combine this list of group students and this list of groups so that I can assign them randomly again into a presentation week. So I loop in a different way. So I'm saying for all of the elements of a set, loop through them until the elements are exhausted. And that set is the number of group numbers. I know that there are 28 students in this class, so there are 14 groups of 2 students each. So I'm telling the program, run this assignment operator 14 times, and each time assign a group to a random week. Once I've done that, I have now a new set of elements, which is a new data type that we'll cover next class, which is a tuple. It's an immutable combination of elements of the same type. So we have a string and a string. So these are the 2 partners. And we have them randomly assigned to the group week 4. And then lastly, I just wanted to pretty it up a little bit. So I just did some formatting, and it yields the group week and the 2 students that are going to be presenting in that week. And this is how I did my group assignment for this class. I wanted to be pragmatic in the approach, and I didn't want there to be any bias. So whoever your group mate is, it was completely random, as is the week that you were presenting. So by the end of the semester, this is the type of thing that I would expect the average student to be able to do. So the ability to use packages, manipulate data structures, and actually influence particular outcomes through the analysis and scripting of data. Paul, I'm not quite sure I understand your question. Yes, there is no expectation that you understood what we just went through, because if you did, then you don't necessarily need to learn all the different materials. This was meant to simply show off what we will be doing throughout the semester, and this is setting the bar for, by the end of the semester, you should be able to look at this particular set of information in code and at least be able to decipher it. If not, write it yourself. Okay, any other questions about this code? And by the way, this code is available on my GitHub that I created just for this class, and I will post that for you all. GitHub, by the way, in case you are unfamiliar, and I highly recommend everybody sign up for it if you don't already have one. It's a great resource for posting code and creating almost like a data science or analytical portfolio. It'll show, you can make it public, and it will show potential employers, friends, family, the types of work that you can do using Python or using SQL or using any other programming language that you're interested in. So specifically, I have the sorting students into groups. This is my GitHub account. For the purposes of this class, you can call me Ben the Professor. That's my GitHub handle, and all of the same code lives here. And I am slacking that to the channel. I also think I posted it in Blackboard. Yes, I did not yet post this second presentation to Blackboard. I will do that after this class. Any other questions? I did a lot of talking tonight. I will not nearly do the 2.5 hours of talking. Hopefully you will all participate much more. Is there a class Slack? I don't have one, but I love Slack. Slack is an amazing technology. So if you all wanted to create a class Slack, I am power to you. I will not be the one that will facilitate it, but be my guest. Bradley, I'm putting you in charge of, you can be our class Slack moderator. Do you approve? All right, Bradley apprehensively approves. How will I take attendance for classes going forward? Going forward, I will learn all of your names. If you do not attend, I will know, mostly because I will either Usually for the first few classes, I will mark it in a ledger, whether or not you are here or absent. But moving forward in the class, I think we have every seat available. I'm sorry, every seat in the lab is taken. So if there's an empty seat, I will simply inquire who is not here today. And that will be my mechanism for class attendance, more or less. The classroom for this lab is Hines Hall. I believe it's 27. It's in the basement floor, 027. Also, I believe it's in the syllabus. Any other questions? This is like ask me anything. Am I a gamer? Um, Depends on the definition. I am not good at video games. I play, what do I play? I play FIFA. That's about it. And I'm not very good. The Patriots will not win the Super Bowl. The Saints will win the Super Bowl. I do not play Dota. That is not a game I play. What is HH? Cuse will not win tonight. Maybe they will. I actually don't know. I know. Oh, haha. You can't write haha. That's where we are today. We have to abbreviate haha to HH. All right. Anything else? What brings me here if I have a job to do elsewhere? My wife is from Syracuse, and she was sick of living in New York City. So I had an opportunity to continue my employment and also move upstate. Where am I from? I'm from Poughkeepsie, which is north of New York City. She's from Syracuse, so we decided that we wanted to live in upstate New York. So I moved to Syracuse. Plus the internet, you can really work from anywhere. I mean, I'm working from a hotel in St. Louis. I'm also burning all of my data because the hotel Wi-Fi wasn't very good. I am in St. Louis, Missouri. I think I said Chicago earlier. I'm going to be in Chicago on Thursday. I've never been. This is my first time in St. Louis. It's okay. It's fine. No complaints. I did not see the arch. Bradley, in terms of the Slack channel, can you make it voluntary? I don't want to enforce that anyone has to use the Slack channel. So, in terms of, I will get back to your question about the head of solution. In terms of the differences between PyCharm and Spider, PyCharm, which is also an IDE, has a different sort of program structure or file structure than Spider. Spider is very limited in its functionality, but I sort of like that. I find that a lot of IDEs are very complicated. I think that PyCharm is a really good IDE for software developers and data engineers. I think that it's a really great environment for testing and debugging, where Spider is a little bit more designed for memory management and things like that. I find PyCharm to be a little overwhelming. What is it like to be the head of solution? For me, it's a great opportunity to work on a lot of different things. I love to see changes take place in organizations, and I think being the head of solution gives me opportunities to both apply data science techniques and actually script solutions, but I also get to go and talk with customers. I also get to work with our research and development team and our algorithms team to help design workflows that are less technical and more business focused. So it gives me an opportunity to both be technical and non-technical at the same time. I think that Steph Curry is the greatest of all time. Any other questions? I have no other additional material today. I'm actually quite exhausted. So anyone that isn't interested in continuing the conversation over the Zoom, you may drop off, and I will see you in 2 weeks. Remember, there are things that you owe me. Download Anaconda. Meet with your partner. There are at least, and read the 5 chapters of the textbook. Good night, everyone. Thank you so much. I look forward to actually meeting all of you in person, by the way.